Let's practice solving linear systems by graphing together. While there are some different strategies such as substitution and elimination for solving these linear systems, in these 4 practice problems we're going to specifically focus on solving them by graphing. For number 1, we have this first linear equation of y is equal to negative x plus 4. Right away, looking at this plus 4, we know the b value of this equation, or the y-intercept, is going to be 4. So we know that we're going to have the point 0, 4 that we can plot on the graph. Okay. The other thing to note right away is that we have a coefficient of negative 1 that's in front of the x here. So we know the slope here, or m, is equal to negative 1 because that's the coefficient for x. Now, we can also write this negative 1 as a negative 1 over a positive 1, or we can think about this as a positive 1 over a negative 1. Both of those are true. Now let's go ahead and graph this first equation. So we knew that b was equal to 4, so we knew the point 0, 4 is the y-intercept. Now I'm going to say that every box is worth 1 on this graph, so here's where 0, 4 would be on our coordinate plane. Now that we've plotted our y-intercept, it's time to look at our slope, which we know is equal to negative 1. So remember, slope is rise over run, right? So this negative 1 means we go down 1. This means to the right 1. So we could follow those directions, and from our y-intercept, we could go down 1 to the right 1 and plot a point. And you can keep doing that over and over again if you want to plot a few more points, all the way down to maybe an x-intercept over here. Or we could go ahead and go up 1 and then to the left 1. That would also be valid. So we go up 1 and to the left 1. And if we went and did that, that would be over here to the top left. And we could plot a few points in this direction as well if you would like to. Technically, you only need 2 points to draw that line, but sometimes drawing a few more helps us out. So this would be the graph for this linear equation. All right, what about our other equation here? We have y is equal to 2x minus 8. So right away, let's take a look at this minus 8. So that tells us that the y-intercept, or b, is equal to negative 8. So we are automatically given that point of 0, negative 8. So right away, let's go plot that on our graph. Negative 8 is all the way down here on the negative part of the y-axis. And then let's figure out what our slope is here. So our slope is actually just going to be this 2. That's right over here, kind of hard to see that. So our slope is going to be 2. I'm going to write m is equal to 2. Now as a ratio, you can think about that as a positive 2 over a positive 1, because a positive over a positive is still positive. Or you can think about this as a negative 2 over negative 1, just because a negative over a negative is still a positive. So we can go ahead and say that if m is 2, we can go ahead from our y-intercept and go up 2 and then to the right 1. So if we go ahead and did that, we would have this point here of up 2 to the right 1. That would be right over here. We could also do that over and over again and keep getting more points that are on this line. And if you wanted to use this ratio of negative 2 over negative 1, that would just be going down 2 and then to the left 1. So we could put a point down here as well. So whatever is more useful to you in whichever case you are doing this in. Drawing a straight line through all these points and putting some arrows on the end of it, you can see that these two linear equations do indeed intersect with each other here, right? So we can see at this exact location, this is the solution for this system of linear equations. So what are we going to write for this solution? Well, we just write the ordered pair here, and this is going to be, looks like 4, 0. So the ordered pair, or the point where the two linear equations intersect each other, is going to be what we call our solution. So this is the only ordered pair that would work for both of these linear equations. If you substituted this 4 in for x into this equation here, this would be negative 1 times 4, which is going to be negative 4. Negative 4 plus 4 would be 0, so y would equal 0, so that makes sense. It's 4, 0. And if you substitute this 4 into the second equation, we get 2 times 4, which is 8, and then 8 minus 8 is 0, so that y would equal 0, which also then makes sense. Here's number 2. For number 2, our first equation here is y is equal to 2x plus 2. So let's start off with the y-intercept. That's usually the first point that's easy to plot. So this positive 2 here lets us know that b is equal to 2. Remember, our whole y equals mx plus b. So we're given the point right away of 0, 2, and we can go ahead and plot that right on the graph right away. So 0, 2 would be the positive part of the y-axis, and we could put that right over here. Now, what's the slope for this linear equation? Well, m is equal to 2 here, so we can go ahead and write m is equal to 2. Now, that's also can be written as a positive 2 over a positive 1 as a ratio, so that's our rise and our run. Or we can write negative 2 over negative 1, because that will also be a positive 2. So let's go ahead and use this first ratio. Maybe let's go ahead and go up 2 and to the right 1. It should be a positive slope here. So if we go up 2 and to the right 1, that would be up here over in quadrant 1. If we can keep going up 2 and over 1, we can plot more points if we would like to. Again, not necessary, but I just like to do it. Then if we take a look at the other ratio of -2 over -1, we can go back to our y-intercept and just drop 2 or go 2 down and to the left 1. So we can go down 2 to the left 1. That's actually going to be our x-intercept right over here. Keep going down 2 and to the left 1, and you can see that this will continue our graph. Drawing a straight line through each of those points, we get the graph for this first linear equation. Now, as for our second equation, we have this y is equal to 4x plus 6. So let's follow the same process here. It's nice that these are in slope-intercept form. So this positive 6 means that b is equal to 6. So we know this y-intercept is 0, 6 right away. So let's go ahead and plot that down. We have to go to the origin, go up 6 units. I think it's going to be right here along the positive y-axis because it's plus 6. And let's go ahead and figure out what our slope is here. So our slope is going to be this positive 4 over here. Again, if it's hard to see, I'm going to draw a little arrow here so it's a little bit more clear. And so m would be equal to 4. And if you're trying to think about that as a ratio or a rise over run, we can think about that as a positive 4 over a positive 1, or we can think about it as a negative 4 over negative 1. Okay, so let's go ahead and follow that first ratio here. Let's go from our y-intercept and go up 4 and to the right 1. If we go ahead and go up 4 and to the right 1, you're going to notice that we are going to run out of space very quickly. So that's why it's helpful to also know that we could go down 4, or we can go down 4 and to the left 1. So going back to our y-intercept, if we go down 4 and to the left 1, that'll be located right over here in quadrant 2. We can go down 4 and then to the left 1 again. And we can go down 4 and to the left 1 again. So we're down here in quadrant 3. Once you have a few of these points and you feel comfortable, go ahead and draw a straight line through them and then throw some arrows on there and try to see where these two linear equations, their graphs, intersect each other. So actually you can see hopefully right here, hopefully that's clear enough, that this specific coordinate or this location here is the solution. And that's in quadrant 3, so looks like it's going to be -2, -2. And that should be the solution here. Just going to go ahead and write that our solution would be -2, -2. So this is the only point that would exist on both of these two linear equations. So if you want to check this, we could take this x value of -2, substitute it in for this first equation up here. So 2 times -2 is -4. -4 plus 2 is equal to -2. So y would equal -2, which it does. And now we can go ahead and take this -2 for x and substitute it into this bottom equation. And 4 times -2 is -8. -8 plus 6 is also equal to -2, which then matches this y value that we have over here. So -2, -2 is the only point that works and is on both of these two linear equations. Here's number 3. For number 3, notice that our equations are not in slope-intercept form, they're actually in standard form instead here. So our first equation is 2x minus 3y is equal to -1. If we go ahead and write that equation out, let's go ahead and rearrange it so we can actually graph this thing a little bit easier. So 2x minus 3y is equal to -1. We want to turn this into slope-intercept form because that's the easiest form to really graph from. So we want to isolate that y. So let's go ahead and take away 2x on the left side. Let's go ahead and do the same thing on the right side. If we take away 2x on the left side and the right side, we should then get this equation of -3y is equal to -2x minus 1. Okay. Now if we want y to be isolated, we should then go ahead and divide both sides by -3. If we go ahead and do that, then our equation here really should say y is equal to +2/3 x plus 1/3. Okay, that should be the equation of this first one written in slope-intercept form. Now that we have this equation in slope-intercept form, we can see that our b value here is equal to 1/3. So we know we're going to have a point of 0, 1/3 for our y-intercept. So let's go ahead and plot that. It's going to be 1/3 up this box here. So let's go ahead and do a rough estimate. I think that's pretty good. 1/3 up a box here. Okay. Next, we're going to take a look at the slope. That's going to be a 2/3, right? So that's going to be our m value. So you can either think about that as a +2 over a +3, or you can think about that as a -2 over a -3. So using this first ratio of going up 2 and to the right 3, we can go ahead and go up 2. So that's going to be 1, 2, and then 1, 2, 3. Now keep in mind, we have to make sure we're staying a third of a box here. We can also go up 2 again and go over 3 units to go ahead and continue that. So I'm just putting 2 dots here that are in that direction, or we could also go down 2 and to the left 3. So if we go down 2 and to the left 3, that would be right about here over in quadrant 3. And we can go down 2 again, 1, 2, and to the left 1, 2, 3, and that should be another point over to here in quadrant 3. Once you feel comfortable and you have a few points that you can make a definitive line, go ahead and do so. So this would be our linear equation here. So if it's a little tricky to go in between the boxes, just try to estimate the best you can. Graphing is definitely a good technique, but can be a little bit tricky to do accurately, which is why there are other methods. So this should be a pretty accurate graph for this one though. All right, just to get a little bit more space here, let's go ahead and move this work. Now let's go ahead and take a look at our second equation of 5x plus 2y is equal to 26. Now this one's also written in standard form, so we're going to have to maybe put it into slope-intercept form so we can figure out what the y-intercept and what the slope is. So I'm going to go ahead and write down here, we have 5x plus 2y is equal to 26. And if we want it in slope-intercept form, we need y isolated. So let's take away 5x from the left side and take away 5x from the right side. If we go ahead and do that, the 5x's on the left side are going to cancel out. On the right side, we're going to have that negative 5x then. So let's go ahead and rewrite this. We're going to have 2y is equal to negative 5x plus 26, just rearranging a little bit. And then we can go ahead and get y alone with the coefficient of 1 by dividing everything by 2. If we go ahead and divide everything by 2 here, then our equation in slope-intercept form is going to be 1y, or y is equal to negative 5 divided by 2 is going to be a negative 5 over 2x. And then 26 divided by 2 is going to be a positive 13. So this would be our linear equation written in slope-intercept form. Now, what does this positive 13 tell us? That means our y-intercept here is going to be 0, 13, which, as you can see, that's not going to actually fit on our graph here. So that's going to be a little bit more work for us because I've already scaled it this way, but I can show you how we can maybe deal with that if we can't fit it on the graph at this point without restarting. And then let's just identify the slope while we're at it here. So we have this negative 5 over 2. So you can think about that as either a negative 5 over a positive 2 for the slope, or you can think about it as a positive 5 over a negative 2. As long as one's negative and one's positive, we can use either of those ratios. Okay, so this y-intercept of 0, 13 is not going to fit on our graph. So can we come up with another point to use, because we can't really put that on here? So at this point, really, you can just choose any value for x that you think would be, less than 10, and hopefully a y value out that would be less than 10 as well. So we could plot a point on this graph. I'm going to go ahead and make up a value of maybe 2, right, for x here, because that's not a terribly big number. So let's say x is equal to 2. Okay. Now 2 is definitely going to be an x value that will fit on this graph. We can go ahead and substitute it into the second equation to figure out what the corresponding y value would be, and hopefully that's going to be less than 10, so we can fit it on this particular graph, right? So again, you don't have to choose 2, you could totally choose 1 or something like that as well, something small. So let's say 5 multiplied by this 2. So we're going to have 5 times 2, and then it's going to be plus this 2y. And that's going to equal 26. So 5 times 2, that's going to be 10. So we have 10 plus 2y is equal to 26. If we take away 10 from both sides, we're going to go ahead and say that 2y is equal to 16. And if we divide both sides by 2, we can say that y is equal to 8. Okay, so we just found out that when x is equal to 2, y is equal to 8. So that would be another point that we could maybe put on this graph. So it looks like 2, 8 would be something that we could fit on our graph, just because we have 10 boxes and I scaled everything by 1 here. So instead of plotting this 0, 13, let's actually plot this 2, 8. Again, it's another point that would be on this graph. So I'm going to go ahead and plot 2, 8. And that's going to be right here. Again, 0, 13 is on the graph and it's the y-intercept, so you may want to use that. But again, my graph paper is smaller here and I didn't scale ahead of time. And so I'm going to plot 2, 8 because that's another point that would be on this graph. Okay. Now from there, let's go ahead and use the slope. Okay, so I can go down 5 and to the right 2 here. So if I go down 5, 1, 2, 3, 4, 5, and to the right 2, that would be located over here in quadrant 1. Then I can go down 5, 1, 2, 3, 4, 5 again, and to the right 2. This is down in quadrant 4. Okay, I think 2 points is enough here. I don't really recommend using this plus 5 to the left 2, just because you're going to run out of space. Notice how you'll go up 5 and you'll be out of paper. And actually, that should be right around where the 0, 13 would be. So once we have a couple points, we can go ahead and draw a straight line through them and then throw some arrows. And hopefully you can see there is a nice location here where the two lines do intersect. So you can see right over here, this point looks like it's pretty nice and easy to use. So it looks like it's 4 to the right and up 3. So it's over there in quadrant 1 here. So +4, +3. We can go ahead and conclude that the solution for this system is going to be 4, 3. This is the only point that would exist on both of these two equations. If you want to go ahead and check this, you can take this 4 for x, substitute it into that first equation. So 2 times 4 is going to be 8. Then take this 3 and substitute it in for y. So that 3 times 3 is 9. So we have 8 minus 9, and that does equal this -1. So that checks out for that top equation. Then you could take this 4 for x and substitute it into the second equation, or the bottom one. So 5 times 4 is 20. Then take that 3 and substitute it in here, so that 2 times 3 is 6. So 20 plus 6 does equal 26. So that does check out as well. Let's check out one more example in number 4. So for number 4, we have this first equation here of -5x plus 3y is equal to 3. Now, just like the last example, we have in a standard form equation, so we don't know the slope or the y-intercept, so it's kind of hard to graph right from the start. Let's go ahead and rewrite this equation, and let's see if we can figure out more information here. So we have -5x plus 3y is equal to +3. Let's go ahead and turn it into slope-intercept form, so we need y by itself. Now, to get y alone, let's go ahead and start by adding 5x to both sides of the equation, so we can get that 3y completely by itself. If we go ahead and do that, then the -5x and +5x will cancel on the left side, so we get 3y is equal to 5x plus 3. And then we're going to go ahead and divide everything by 3, so we get a coefficient for y to be 1. So 3 divided by 3 is 1, so we're going to have the equation here of y, or 1y, is equal to 5 over 3, or 5/3. That's going to be x, and then plus 1, just because 3 divided by 3 is equal to 1. Okay, so looking at this plus 1, that tells us that our y-intercept here is going to be 0, 1. That's our b value. Okay, so we can plot that y-intercept right over here on the positive y-axis, right a little bit above the origin. Then looking at the slope, we have this +5 over 3. So we can think about that as a +5 over a +3, or we can think about it as a -5 over -3. Either of those would be okay. So if we went and used this first ratio, that would be going up 5 and to the right 3. So we can go ahead and go up 5, 1, 2, 3, 4, 5, and to the right 3. That would be up here in quadrant 1. I don't think we have enough space to do that again, so let's go back to the y-intercept and go down 5 and to the left 3. So 1, 2, 3, 4, 5, 1, 2, 3. So that looks just about right over here in quadrant 3. Drawing a straight line through these 3 points, we can see that this would be the linear equation. Now for the second equation of 4x plus 3y is equal to 30. Again, this one's in standard form. Let's go ahead and rewrite this. So we have 4x plus 3y is equal to 30. We would like y to be isolated by itself. Let's go ahead and subtract 4x from both sides of this equation. If we go ahead and subtract 4x from both sides, then the 4x is going to no longer be on the left side, so we're just going to have a +3y is equal to -4x plus 30. If we just do a little rearranging on the right side, then we want it to be 1y on the left, so we can divide by 3 on both sides of this equation. 3 divided by 3 is going to equal 1y, so we're just going to write y is equal to, then we have -4 over 3, so that's going to be -4/3 for the slope, or m, and then plus 30 divided by 3 is equal to 10. So this would be our linear equation in slope-intercept form. This +10 lets us know that our y-intercept is going to be 0, +10. We can go ahead and plot that one. It's right on the edge for this graph that we have here. So let's go ahead and put that right up here at the very tippy top of the graph. Good thing we have 10 boxes there. And let's go ahead and see the slope. We have -4 over 3. So as a ratio, we could think about that as a -4 over a +3, or we could think about it as a +4 over a -3. However you would like to think about that. I don't think we're going to use this second one, because that means we have to go up 4, and we're already on the very tippy top. So it's good that we have a second option here. We can go down 4 and to the right 3. So if we go down 4 and to the right 3, let's go down 1, 2, 3, 4, and to the right 1, 2, 3. That actually crosses the second graph perfectly right here. We could do that one more point, so let's go down 1, 2, 3, 4, and to the right 1, 2, 3. That would be a second point here. So I think that's enough points. Drawing a straight line through these 3 points, we can go ahead and draw arrows here, and this would be the graph for this second linear equation. So it looks like when we were sketching our second linear equation and plotting those points, we have this nice location where they intersect. And so it looks like this is in quadrant 1, so it's a positive positive. From the origin here, it looks like it is 3 units to the right, and then it is 6 units up here. So I'm going to go ahead and say that this coordinates of this point is going to be +3, +6. Therefore, we would just go ahead and say that that would be our solution of 3, 6. Now checking this one more time, if we take this +3 for x and substitute it into this first equation, that's -5 times 3, which would be -15. Then we could take this 6 and substitute it into the second term here, so 3 times 6 is 18. So -15 plus 18 does equal +3, so that checks out. And then if you take this +3 and substitute it into the second equation, 4 times 3 is 12, and then take the 6 and substitute it in here. 6 times 3 is 18, so 12 plus 18 does equal 30. So this also helps show us that this does make sense to be our solution. So there you have 4 different practice problems where we were solving systems of linear equations with 2 variables and 2 equations by using the strategy of graphing. Okay, if they're already in slope-intercept form, it's pretty straightforward to just go ahead and start graphing. If it's in standard form, just rearrange it a bit so it's in slope-intercept form so you can graph it as well. Where you see where the 2 graphs intersect, that is the solution, okay? If they don't intersect each other and are parallel, that means there's no solution. And if they are 2 lines that are right on top of each other, that means they're the same equation, there are infinite solutions. We don't have those here in these 4 practice problems, but if you'd like to see any of those, please leave a comment down below. I'd be happy to try to get to making a video on those so you can see what they look like as well. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.